Thank you for attending today's Pegasus office hours. My name is Mats Rynch. I'm a Pegasus developer, and I'm also a member of the Open Science Grid's user support team. So today we'll be highlighting Pegasus running on the Open Science Grid, and I think this is going to be interesting for people, users that are looking for a new execution environment, as well as OSG users that maybe wants to have a more formal setup for their jobs. Let's start with an outline. Let's see here. Oh yeah. So first, as you heard, we are recording this session. We will make the video available on our website later on. It's also an interactive session, so please interrupt at any time if you have any questions or if you want me to clarify anything. I can see the chat, but I might not pay attention to it all the time. So if I don't see the chat, just interrupt me by using microphone, and I'll stop and answer your questions. The outline will cover some stuff, but we're going to just do slides for maybe 10-15 minutes, and then we're going to drop down to the command line and run workflows and kind of examine the internals that way. What we're not going to do a full Pegasus tutorial. We are going to touch on a lot of different capabilities, but it's not going to be a complete list. The things that we will touch on a lot is data transfers. We're also going to maybe look a little bit on provenance data and reproducibility. Now, Open Science Grid is this system that we have here in the US that connects about 120 different sites. And from the user's point of view, what's interesting here is that your jobs could land on any of these sites. And the implication here is that you have to be careful when it comes to data. You have to be able to bring your data with you. And when you're done computing, you have to stage that data back to a central location somewhere. So data management is a big part of running an Open Science Grid. And we will see how Pegasus can help with managing that parts of those aspects of the computation for you. This slide is just showing that what OSG provides, it's a lot of hours, right? We're talking about 3.5 million CPU hours a day currently, or over 1.5 billion hours a year. My point here is that, yeah, it could seem a little bit that you have to jump through extra hoops to run an Open Science Grid because of the data transfers and the non-shared FS setup that you end up with. But there's also a lot of cycles to be had. So it might well be worth it to explore Open Science Grid for your workflow executions. The particular corner of Open Science Grid that we'll be talking about is called OSG Connect. And there are many different ways into OSG, like if you're part of a bigger collaboration, you might have your own gateway in there. But this one, OSG Connect, is for dedicated to individual scientists or small labs, small projects that are looking for more of a hosted environment. And that's just what OSG Connect is. It provides things like a login host and software catalog and storage. And it is open to any US researcher or US a researcher with part of a US collaboration. And the link to follow is the one that's on the bottom here of the slides, osgconnect.net, where you can read more about OSG Connect and sign up for an account. There's OSG Connect also provides this user support page, and we will be using this later on because this is where you can find information about, for example, how to run Pegasus in Open Science Grid. So the tutorial that I'm going to walk through you can find that after this event by going to this support page, support.openscienceweek.org, and here in the search box, just type Pegasus, and you will find that. And it's going to be a self-guided tutorial, exactly the one that we're doing today. So you can play and you can use that as a base for your own workflows when you want to implement them. One of the services that we're going to use in this workflow, and this is OSG Connect specific, it's called the Stash Store service. And if you are from a different OSG virtual organization, you might have something similar in your in that setup, but you might have to change this workflow a little bit. If you're running on OSG Connect, this will work out of the box. So Stash, when you log into one of the login hosts, it just looks like a really big petabyte sized file system. But what's neat about this is the services that are attached to it that allows you to do data management. So to get data in and out of it from your desktop or laptop, you can use Globus Online, for example. There's also an HTTP endpoint where you can use. And there's specific commands that will push and pull data into Stash, and that's what we're going to use in the workflow. Specifically, the StashCache suite of tools. If you want to know more about it, there's a link here on this slide as well. But the way that this works, that makes it exciting for workflows, is that when we read from StashCache, there could be transparent proxying going on, and that's what we see in this picture here, where the origin service is OSG Connect. There's a cache layer, and then we have the jobs at the bottom. So the point here is that we get automatic caching, and if you have workflows that has a lot of repeat data, like jobs are using the same data over and over again, this cache layer is going to be very, very nice for you. The other thing that's nice about Stash, and this is a pretty recent development, is that we can write stuff to Stash in transparent fashion. That means that the credential handling is done as part of your job. You don't have to initialize proxies or manage any credential. It's all that stuff is taken care of on your behalf. So your job can just run the StashGP command and copy stuff back to Stash without you worrying about credentials. This is a kind of a busy picture of what was going to happen today. So on the left here, we'll start with defining a workflow, and it's not going to be this diamond shape, but it is going to be a set of jobs that we will then have the Pegasus planner plan down into an executable workflow, and that's what we see here in the lower left corner. And this planning step will do a couple of things. It will add jobs in, like data staging jobs. It will also wrap our executables. You see this little extra white ring here that wrap those executables into some data management steps. And that's what we see in an exploded view. If you follow this job up onto an OSG compute site, here's the job J. And if we zoom in on that job, we'll see that even the job looks a little like a workflow itself, in the sense that it has steps like creating a directory, staging data in. It's going to do integrity checking of the data, run the job, obviously, and at the end of the job, it will add some checksum generation, stage data out, and then clean up. So this is stuff that the workflow system adds to your workflow without you having to worry about it. You see the staging set we're going to use is Stash. So all the jobs that we run will pull and push from Stash. And on this pull arrows, the arrows going into the job, we see that there's a caching question mark, because we don't know if it will be cached or not, but at least it's passing through that layer. And so for some workflows, it's going to be more important. But even if you don't do caching, it's a very nice way of accessing the data. And then on out, that was the credential, provided credential rights that I was talking about writing back to Stash. We might come back to this picture later on if there's some some questions about it, but I think that this will help you understand the workflow itself. Now I'm about to drop down on the command line and start that part of the session. But before I do, is there any questions that people have before I go on? There's nothing on the chat. Anything else? Okay. All right, so let's go to the command line. As I said, this tutorial, it's available here in the support opensciencegrade.org. You can go there and just type in Pegasus and you will find it. We'll use this tutorial command. This is a command that's provided by the OSG Connect system. It basically will pull down a tutorial from GitHub and allow you to work on it from your own account. So let me get out of here. Let's do one more and then get into my terminal. Okay, not that terminal. There we go. All right, so I'm going to start from the beginning here. Okay. So I'm going to log into osgconnect.net. Right. So this is the login service that provided by OSG Connect. And I might probably have to clean up here first. Tutorial Pegasus. Okay. All right. So now, first we can look at this web page that describes the self-guided tutorial. And so in it, first there's a little bit of an introduction to Pegasus that you can read about the different capabilities that Pegasus has. Some of the parts we're going to go over these when we talk about the workflow, so I'm not going to do it right now. And then it has an example workflow, and this is where we're going to start. So what we're going to do is we'll start with this tutorial Pegasus here that will pull out the workflow into our home directory. Right? And it could take a little bit of time. We'll see. Okay. So this is being pulled from GitHub. A version of this on GitHub as well. If you don't want to go through OSG Connect, you can also get it directly from GitHub. I will have to dig up the link for that though. But all right, so tutorial Pegasus. In here we have two examples. We'll start with this first one. Okay, and if we look in this directory, so this is a sample workflow, and we have a few files here. First, we have something that will do our computation, and in this case, it's a simple example used for demoing. It's a word frequency tool, and we have a set of inputs. So if we look at the inputs first, in inputs, you will find a set of books. And so what the computation we want to do in this sample is word frequency on these books, right? So we can try it on the command line by running word frequency inputs, and we can take one of the books, and we'll just look at the results. So it runs pretty quick, and it will give us this word frequency analysis. And so the goal here is to set up a workflow that does this for us. To do that, to do a Pegasus workflow, the first thing we need is a Dax generator. So Dax generator is what generates the abstract workflow. And the one that's provided here, it's in Python. There's you could write this in Perl or Java as well. There's different APIs. I think there's an R API as well. And what we're doing is first we're using Pegasus provided Dax API. So there's you import this and then you use that in your code. In this example, the first thing we do is we define the executable that we want to use. And that was the one that we just demoed, the word frequency. And we are going to tell Pegasus where to find a copy of this. So that's what this line does. It says, we know we need this executable. Go and get it from here. And once we have that, what we're going to do is we're going to loop over the inputs. So we're going to one task per input. And for each one, we're going to define a file, input file in this case. So that's using the file class. And again, we're going to tell Pegasus where to find a copy. And this is important. This is something that, workflow systems, they track the files. So in this case here, we have something called a logical file name, which is just a relative path to that file. And then we also have to tell it where to find replicas. In this case, it's just a simple, here's a copy in the file system. But this could be other things. It could be a URL to, HTTP or S3 or grid FTP. It could be remote data that you want to pull in, and the workflow system will do those data transfers for you. So once we have told Pegasus that there is an input file, we're going to add a job. So we're using the job class for that, and this word frequency name, well, it refers back up to the executable that we registered before. And we also define a new file as an out file, arguments, which is arguments to the word frequency command. It has to know the in file and the out file. And then we also have to specify that the job expects that in file and that out file. You see the link here, link input, link output. So this is part of how Pegasus tracks the files, right? It has to be specifically told what are the input files, what are the output file of each job. And once we have that, we're going to write out this Dax XML, and this is the abstract definition of this workflow. We'll look at it once we submit it and see what's in there. The second thing we should look at is the site catalog. So this is an XML file that describes our environment. And in this case, we have three different sites defined here. We have the first one is a local site. This is always required. It's basically the submit host, and it will tell it specifically. This part here will define where our outputs will go. So you can set any path here, but all we're saying is we're going to put it in a specific work directory and leave it there. The second site is our staging site, and this is the site that defines stash, right? So this is the stash handle. There's a path here, actually we'll drop down and we'll look at stash. Like if I look in that directory, for example, I mean I probably have a lot of crap in there, but it's a big file system. So you see 1.1 petabytes. That's used for a lot of OSG users. It's well used also, 94%. So, but that's a good place for you to do your data staging. That's also where the stash EP will do a pull and push against. So going back to here, the last site we have is the execution site, and this describes the Condor pool that we have that we use for on this side of Open Science Grid. And I guess the most interesting keys here are like the requirements. So in our case, we say we want to run on Enterprise Linux 7, has modules. This is we want access to the OSG software stack, basically. And we have a special key here today. This is something that's just going to sit here for today, but it's excluding some sites that were misbehaving, and before that gets cleaned up, I'm going to leave it in here for the tutorial today, and I'll remove it tomorrow. So if you do this later on, this part will probably be missing. We also describe the resources we need, the number of CPUs, memory, disk, and we want to use one to stash cache, so that it's a hint that we want to use stash for staging. Okay, so the last script we want to look at in here, again, let's look at the files, is the submit script. And this is a helper script. You don't really need this, but I find it very helpful because I can't remember the steps sometimes. In this, we have a little bit of environment setup. We're using a pre-release of Pegasus, and I will get back to that, why we're doing that a little bit later. We want StashCache. We want StashCache commands in our path. And we also set up the work directory, which is in local scratch this case. So we are separating where we run the workflow from and where we do the data staging. The reason for that, we could use Stash as well, but Stash is this, optimized for big data kind of file system. Instead, we're going to put our workflow on a local disk that provides a little bit better I/O when it comes to writing log files, for example. And the next step is we're going to generate our Dax. So that's running that Dax generator that we looked at just earlier. And we're going to generate a sites XML file from our template. This is really just filling out the work directory that we define up here. So but it allows us to use environment variables in the site catalog. And the last thing we're going to do is this Pegasus plan command. And this is the kind of the heart of Pegasus, where it takes the input, where we take that abstract workflow, the Dax XML, and we make it an executable workflow by planning it against a certain site, telling Pegasus that there's a staging site we want to use, where we want outputs to go, and a little bit about clustering, which also will come back in the second round of this example. So the next step is to submit our first workflow and see what happens. So again, any questions? All right. Well, we'll submit this, and what we'll get back is Pegasus saying that we generated our executable workflow and submitted it to Condor. So the two things to pay attention to here. One is that there is a dagman, a specific log.dag.dagman.out. We can look at that a little bit later, but this file is where dagman will log all the jobs being submitted and finishing up in the system. So if there's any issues with the workflow itself, this is a good place to look. Now, the other thing we'll see is that the Pegasus says that it started it and it gives back a base directory. This base directory is basically a handle to your computation. This is, think about this as a job ID. And you use that to interact with the system. So, for example, it says you can monitor a workflow by running this command. So we'll run this command using that run directory as an argument, and it will tell us what the state of the workflow is. So we'll see here are our 6 word frequency instances, 1 per book, and we'll see that 2 of them are running. 5 of them are running, sorry, and 1 is idle so far. And we can run this again, and we'll, get a little bit more progress. The part on here, tells us the progress of it, especially the % done here, and what different states the jobs are in. So unready is the most interesting thing. If you think about a graph, unready means the nodes in that graph that we haven't gotten to yet. We haven't computed on their parents yet. So if we run again, we'll see we're getting closer to done, and you will see these jobs, which are the auxiliary jobs of the workflow. If you think back on the picture that we had where I said when we plan the workflow, Pegasus will add in jobs. Well, these are two examples. One is, data staging job. Another one is cleanup job, and that will keep on, removing unneeded data from that scratch space that we don't need. That's not needed by the workflow anymore. To keep the footprint of the workflow small. So we can run again. We're almost done. It's still cleaning up a little bit. So this is a different cleanup job. The last one was cleanup level 3. This is level 4. We're getting there. We also see that there's only one job that's unready, one in queue. And here we go. One more job. This is probably the final cleanup, yeah. Okay, success. So now I'm going to clean this up a little bit to show you again. All right, so now Pegasus is done, 100% success, right? Using this handle now, even though the workflow is done, this handle is still valid, and we can still interact with the workflow based on that. So one of the things we can do, we can say, give us some statistics about how on how that workflow did. So we're using that run ID again, and Pegasus will calculate some runtime statistics. On the top here is some description of it. Sorry, why isn't this scrolling? All right, so there's some description of what the different metrics are. And at the bottom here, we'll see a summary, number of jobs and tasks we ran. We'll get some runtime information and how long time this took. Obviously, being a demo, this is tiny. It's really no interesting data here. But if you ran a big production workflow, what you would see, for example, is that the wall time would be maybe a day, and this one would be years, right? Like you want to have parallel computations, so the cumulative job wall time would be much bigger than the wall time of the workflow itself. There's also a little bit stats about the integrity checking, and let's dig into one of the jobs to see what Pegasus did for us. So if we log in, and if we go back into this directory again, now we can cd into that run directory and see what Pegasus actually generated and used. So in here we will find the main thing is the DAG. This is the HG Condor DAG that Pegasus generated and Condor executed for us. But as mentioned, the most important file in this is the .dag.agmin.out. This is 99% of the time this is the file that you really want to look at. And our workflow was successful, so we can there's nothing really interesting in here, but one of the things that you could look for is this, which is regularly a Dagman puts out this little description of jobs it knows about, and again the state of those. So if you had a workflow that was failing, for example, you would see jobs showing up in this column, and then you could start looking in this log and see why they were failing. But the other thing to do is that if you have a workflow that fails, there's a Pegasus provided command that will pinpoint the failure for you. Now, this was a successful workflow, so it's not going to tell you anything, but Pegasus Analyzer, again, another good command to kind of have in mind, it would tell us if there was any failures, it would list them here, and it would try to help you tell you what files would look at and what went wrong. So it's a really good command to remember. The other thing I want to look in here is if we go down into one of these subdirectories where the jobs are, so we can, if we look at these word frequencies here, we'll see there's 1, 2, 3, 4, 5, 6, which corresponds to the 6 input files that we had. So we can look at one of these files. So Pegasus generated a Condor submit file. It generated a metadata file, and this is part of metadata for the job, for example, integrity data. and it generates this shell script that is the wrapper around your job itself. So we can look at that one, and it's going to be, there's a lot of stuff in here that you just don't want to worry about. But we can see that the stages here corresponds to the first image that we looked at. Actually, let me switch back to that for a second, and we'll look at that view percent. There you go. Okay, so what I want to show you is the thing that we have looked at, that we are looking at the command line now, is this part here, right? So we're going to look, and we're going to see the creator. We're going to see we're going to see the stage in. We're going to see the integrity checking, the execution of the job, and the cleanup and all that stuff, right? So keep that picture in mind, and then we'll switch back in here, where the first one we'll see is staging in. And we will see here that we have a file, like this is one of the books that we looked at earlier. It's coming from Stash, so that's what we want to see. So it has this URL that it built using the site catalog and the files in the workflow, right? And what we want to do is we want to have a copy of that into the working directory. So all it does is pull from this remote location, put it in a working directory, make it available. And the other file that we want is the executable, the word frequency executable that we started this whole thing with. Okay. So the Pegasus will do this part. It will do the transfer using Pegasus transfer. The next step here, the next major step is checking file integrity. So what this does is it looks at the input files, and this files is the Alice in Wonderland. So it will look up in the metadata, and it will run a checksum on this file and make sure that it matches the known checksum from the earlier in the workflow. So this will the idea here is to provide extra integrity checks in the workflow. So we do this before using a piece of data, and then when we generate a piece of data, we'll add integrity to the metadata catalog for that. And here we're running the word frequency. You see this part here. We're running wordfreq on that file. This is also wrapped in something called Kickstart, and the reason for that is the provenance data. So if we exit out here, and let's see what we get back for our job. So this is the standard out of the job. And what it is again, big XML record. And this is the state captured from where this was executing. So the whole idea is that you should be able to go back saying, where did this execute? What was the environment? How much resources did it use? All that stuff is captured in here. And this is then used in tools like the Pegasus statistics tool to calculate runtime and other stats like that. So we can look at, for example, there's stuff in here with the duration, job duration. There's stuff about U time and S times used. We will look at, there's a little bit of RAM. And in here is also the standard out and standard error of the job, which we had none. The word frequency tool doesn't output anything, and it will tell us where it ran. So this is host name, but in this case we also have the whole environment. So we can, for example, look at the glide-in site. So we know it ran in Michigan, and we have all this other information in here. Usually don't have to look at this directly, as I said. Usually this is just picked up and put in our provenance database and then used by Pegasus statistics. Let's look at the outputs. So the outputs, we told it to write to this work directory, and then, in outputs, and then it uses this run ID in this case to separate the outputs from different runs. So if you look in here, we can look at one of these files, and we will have the same frequency analysis output that we had in the first run, right? And we ran it by hand. So now what we could do is let's run a little bit bigger example and show one of the optimizations that we could do to this workflow. So we're back in my home directory. We go to tutorial Pegasus WordFreak again, and going back to this self-guided version here. The things I've been going through, like here's the Dax Generator, here's the submit script. It's all in here. So if you want to go back and remind yourself on how this worked, you can go back into here. And the stuff I'm doing now is loosely based on these exercises. It's not exact, but this is, for example, this is what we just did, looking at the head of the output. The next exercise here, exercise 7, is what if we had a little bit more inputs? So there is a separate directory here with many more inputs. So let's copy that into inputs. And in inputs now, we can see we have 1,000 ebooks that we want to do frequency analysis on. But we also know that WordFreak is a pretty short tool, and the overhead of taking those short jobs and scheduling them onto Open Science Grid and get the results back, it's a lot of overhead for those really short jobs. So one of the features that we can use in Pegasus is task clustering, and in the Dax Generator, there's a property or profile here on our executable where we say cluster size. So if we change this to 50, what will happen is Pegasus will take 50 invocations of that, make one job, and send that kind of as a package to Open Science Grid, and then get 50 results back. So it's a more efficient way of packaging up these small jobs. If you have jobs that are like an hour long or hours long, you don't need this feature. But if you have short jobs, this is a nice one to use because it will increase your efficiency. So we'll submit this. And just like before, we'll get executable work directory here, the run directory back. We can run Pegasus status on it. And it will tell us what it's doing. Right now it's just creating a directory. And while we wait on that, let's go into that directory just like we did before and look at one of those jobs and look what Pegasus actually did for us. So if we look, and now you will see there's a merge tag in front of each file here. We'll just look at one of those. And what we should see in here is 50 invocations. So first, that means we have 50 inputs. So here's all the 50 inputs. All the data gets transferred in. Here's the integrity checking. And of all those 50 in one go, by the way, it's like boom, 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 boom. And then we're executing each one. So there's 50 of these execution WordFreak, right? WordFreak executions, and then we stage out 50 of them back to our output site. So, Pegasus status. So the nice thing about this, right, is that it's all handled automatically. All we did was tell Pegasus, why don't you help us by combining these, and then you get all the error checking, all the integrity checking, all that stuff for free. This will take a little bit longer to run. So in the meantime, I'm going to, we're going to come back to this, and we're going to look at a common question we get, and that is, how do I use containers with this? So containers, in this specific case, I'm talking about singularity containers. But the idea is, how do I provide, a more consistent environment, or maybe I have custom software that I want to bring. So in Open Science Grid, that's handled in a specific way. And there's links to, if you want to read up more about this, there are links to it here in this tutorial. And this page will, describe how this is implemented in Open Science Grid is provided for you. What we're going to do is we're just going to look at, go back into the tutorial, and remember there was two of them. We have used WordFreak so far, but there's a Dash containers also. So if you look at this one, it looks almost the same as before, but there's the addition of a summarize task. So we're going to do two things, adding two things to the first round of WordFreak. The first one is we're going to change the structure of this workflow. So there's a picture of it here, right? So the first time around, we just had 6 independent jobs. All this WordFreak just ran independently. There was no structure to this workflow. What we're going to do is we're going to add a structure. We're going to add a summarize job that will do that, looking at the top 5 or whatever it is of each result and give us that into one summarize file. And so we have to add, dependencies in our graph and passing files from one job to another one. And also, we're also going to we're going to tell Pegasus that when you execute this, use a specific provided singularity container so that, we have a known environment that we're running in. So let's start with the structure first. So we have added this job summarize. It's a very simple little script, and really it's just doing this head-5 that we ran by hand before. But it is a kind of a good example of what people do in a lot of their workflows. They want to maybe throw away results or summarize them or provide a report at the end. So this is a very common pattern that we do see. Now, the changes in the Dax generator. We can look at the Dax generator and say, how do we do the dependencies? So one of the things we have done, we have a second executable specified. We also have added the summarize job up here, which is, if you think about the flow in the code here, why do we have the bottom job on the top of the Dax generator? Well, the reason is that we want to be able to refer to this job in the loop. So every iteration in the loop, we want to be able to say that there's we want to say that there's a link between them, that the output file of the word frequency is an input file to link input into the summarize jobs, and also that each word frequency job is the parent of that one summarize jobs. So it's, you could obviously build an array or something to keep track of these two pieces of data and then add them at the bottom. That's fine. It's just a convenient way of specifying the child job first and then the parents.
Hey, Max.
Yes.
This is Pat from Vermont. Hey, is that depends necessary since you have the file dependency established?
No, you're right. You could actually do without it, and Pegasus would figure it out. Sorry, it is required if you don't have a specific file dependency. So sometimes you have dependencies between jobs. Let's say that they access a database, right, or something that's remote. We wouldn't know about the dependency, and then you need to specify this. So I just have it in here to be explicit. I guess that's the answer. That makes sense?
Yeah, perfect. Thanks.
All right. So that was the structure of the workflow. So that will give us that graph. For the containers, and that again, this is OSG specific. There, Pegasus does have a standalone container support, if you're running on your own resource and you have Docker or Singularity there, you can tell Pegasus to use that Docker, that Singularity installed to run in containers. But on Open Science Grid, what we do is that we pre-cache your containers for you to something called CVFMS. This is a distributed file system, a read-only file system that is very efficient to read from, and it's especially when it comes to containers. This has a huge impact on saving bandwidth, for example. So the nice thing for running Condor and running Pegasus workflows in this environment is that we don't really have to do anything except tell Condor that, yeah, we want to use this image, and I also want to land on Singularity nodes so that they can use Singularity to use this image. And that's all we have to do. If you're interested in this, there's a whole page or a whole section of that on the support page. There's a set of predefined images, for example, for things like TensorFlow or other things that are hard to provide environment for, but easy to do it as an image. In this case, this image is very simple, but it's just mostly a copy of the standard image but we want to show you that we can how to set up your workflow to do this. So just like before, we submit and it should be all automatic. So we can go back up and see if the one up here is done. Just interleaving these two. So this is the bigger one we did. It's still working. It still have one job left to do. But that's done with all the exercises. So before we run out of time here, I want to open it up for any questions that people might have. Anything else?
I'll start off. This is
Yeah.
Pat again. So if I wanted to customize the Singularity container,
Right.
I wouldn't be able to put it back on CVMFS. It sounds like I'd have to put it someplace else.
Yeah. No. So the way that works is if I actually switch to the web page here, you can go away. So the Docker Singularity images here on the support page. So the way that this is happening is it's really a synchronization from a Docker Hub image to CVFMS. And once you have it registered, so we can go down here. So the point is that you can make a publicly available Docker image. Okay, you tell us that where we can find it on Docker Hub, and we will start syncing it to CVFMS. So anytime you change that image, every time you push, do a Docker push, we will update it on CVFMS automatically. So this is used, it's used by us to provide a set of default images, but it's also used by end users where they say, I want my custom image, I made one, here's the Docker, pointed to my Docker repository, and we will pick it up and use it. And we can look at that. If we look in CVFMS on this, there's a bunch of stuff in here. So some of it is, Open Science Grid, like our kind of specific images. There's things like biocontainers that are a standard set of containers built by the Biocontainers project. We have LIGO stuff in here, so there's bigger projects that have their own, and there's individual users that have their own, right? So this is a mix, a big pile of containers that's in here. And if you feel that one of the ones that we provide are not covering what you need, build your own and let us know, and we'll start syncing it for you. That make sense?
Yeah, perfect.
Yeah. on a side note, the other thing that's nice about this is that we're starting to see that CVFMS is getting picked up by by bigger sites now. So these images are also available on things like, TAC resources and San Diego Supercomputer Center, and I mean, it has become a very nice way of distributing your image. Part of why I'm saying it's efficient, that if we dig into one of these, let's look at that image that we used, which was Pegasus, this one, right? If you look at this, it's not an image file, but it's actually an exploded version of that image. So what happens is that when you start a job in here, we don't need to pull the whole image file. Only the pieces the parts that we are actually touching gets downloaded. So I could put up like a 10 gig sized image, but when the job starts, maybe it's only using 200 megs or something, and that's the only thing that gets pulled down. So and plus that's heavily cached all the way down to the compute nodes. So we're running 500,000 images a day or instances a day, and we can't even measure this on our network bandwidth. I mean, it's a very, very efficient way of doing it.
Oh, that's super slick. Thanks.
Yeah. Yeah, it's been very, very helpful, not only in the workflows, but general OSG users. Many of our OSG users, they don't even know that they're running containers. They just, they say, I want to run on EL6 or a 7, and it happens to be that job runs in a container with a default image. They just don't know about it.
Mats, we do have a question on chat about using private Docker images.
Yes. So we do not support that yet, and the reason for that is it's not really a problem for us of maybe pulling from a private repository, but the problem is that CVFMS is public, right? So we don't want to take something from a private repository and put it in a public environment. If you want to keep your containers close to your heart, you can actually specify an image file instead, and we will just pull the image file instead in your job. So that was, in that container file. Where am I? So here in the sites XML, right? So you could put a path to a private repository here, but I would be careful about it, because it's just, if you run a lot of jobs, you're going to hit that repository over and over again. So, if that's a use case, come and talk to me, and then we might be able to work something out. But in general, our images are public. I think that's the answer.
Yeah, and your answer is qualified on OSG, but let's say if a user is trying to run with containers on a resource other than OSG, and they just want to use their own private Docker containers, then one option is, you just export that Docker image and have it listed in the transformation catalog with the HTTP order file URL.
Right. So in the Pegasus documentation here, there should be a whole container container example and how to do this in your own resource. This does not work on OpenScienceGrid. Like OpenScienceGrid does not give you direct, what's it called? Direct access to Singularity and Docker executables. Like that's part of the I should say security model or the encapsulation of the jobs is to not provide direct access there, and that's why we're using this specify singularity image approach instead. There are other sites like Dursk, for example, that uses Shifter. That has their own kind of, it's more of a HPC environment, but the same idea. They have some kind of solution that sticks your job inside a container, and it works very similar. Like Pegasus can work in that environment as well. You just do a special job queue in that case, so you have a lot of options, I guess, depending on what execution environment that you want to run in.
So one more Singularity question. So I noticed you specified your Singularity image at a execution site level, can you do it at the job level instead?
Right, you can, and these profiles here can be uh, in the job as well. So I could, for example, if I didn't have that here, I could do it in the I could do it, for example, per job, right? Where I said just like I had this profile up here, like I added a profile, right? I could add a profile that says, it would be a Condor profile instead of a Pegasus profile. That would be Condor, and then singularity image.
Awesome, perfect.
Right, and then you could have a separate one for the other job if you want to. Right, so this job would have a different one. Does that make sense?
Exactly.
And then that would be something else, right? But that's, yeah, definitely. If you do that, don't do it in the site catalog. Only do it in the Dax in this case, because they will overwrite each other. So I think, Karen, right? The site catalog would override what's here, right?
Yes,
Yeah.
that's
So
good.
only do it in the Dax generator here instead, and then take it out to the site catalog. Okay, any other questions? I see that we are at our hour mark, perfectly timing. I guess what I should end with saying is that if you have any questions here, you can either email us on Pegasus. There's on the Pegasus website, there's a contact thing, getting in touch. And if you have questions about the Open Science Grid part, that was in the slides. It's user-support at opensciencegrid.org. That goes to our ticket system.
Hey, Matt, this is awesome. Thanks a lot.
Well, thank you for attending, and we'll follow up with you a little bit later. I think we haven't talked for a while, so it would be good to talk again. So thank you all for attending, and we will disconnect and upload a video. Thank you again for attending.
All right.